Hello everyone, good to see you again. I call myself Mr. U.S. Patil, working as assistant professor at Sharad Institute of Technology College of Engineering, Edra, Ichalkarji, which is at Kolhapur district, Maharashtra. Today, in this video, we'll see the robot applications and the general considerations in the robot applications. Here in this video, we consider how robots are applied in the industry. The applications can be divided into 7 major categories. Before examining these 7 categories, it is appropriate to discuss some general consideration in the robotics application even, right? In the general application characteristics, there are certain general characteristics of an industrial situations which tend to make the installation of the robot economical and practical. These general characters are here. Some general application characteristics are here noted down. First is hazardous or uncomfortable working conditions. Second is repetitive tasks and difficult handling, and fourth is multi-shift operations. And after that, how the selecting the right applications while using this robot. If you see here, hazardous and uncomfortable working conditions, in job situations where there are potential dangers or health hazards due to heat, radiation, or toxicity, or where the workplace is uncomfortable and unpleasant, a robot should be considered as a substitute for the human worker. This sort of applications has a high probability for work acceptance of the robot. For example of these job situations including hot forging, die casting, even you can say spray painting, maybe that foundry operations. And if you see here repetitive task, mm, if the work cycle consists of a sequence of elements which do not vary from cycle to cycle, it is possible that robot could be programmed to perform the task. This especially likely if the task is accomplished within a limit workspace. Pick and place operations and machine loading and unloading, these are the some examples for this respective tasks. And another now is difficult handling, where the difficult handling if the work part or a tool involved in the operation is worked, I mean heavy or awkward, it might be possible for a robot to perform that task. The operations involving the handling of heavy work parts are a good example of this, we can say, uh, application here. And a human worker would need some form of mechanical assistance to lift the part, which would add the production cycle timing. Some industrial robots are capable of lifting payloads weighing several hundred pounds even, right? And another is multi-shift operations, where if if you see if the initial investment cost of the robot can be spread over 2 or 3 shifts, the labor saving will result in a quicker payback, isn't it? This could mean the difference between whether or not the investment can be justified even. And the plastic injection molding and the other processes which must be operated continuously, and this kind of examples comes in multi-shift robot applications. And apart of this is very the selecting the right application Not all robot installations have been successful, isn't it? There are enough case histories of misapplications, poorly selected equipment, and a non-acceptance by factory personnel to make a prospective user very carefully, especially in the initial application. The ideal applications would be one which possessed the four general characteristics described in the preceding section. The candidate for robot installation should be subjected to the some kind of or same kind of economic criteria as any other investment proposal concerned with the productivity improvement or cost reduction. If at all possible, the application should be a simple one, especially on the first robot installation, where success is important for general acceptance of the technology. Here, in general, electric company uses some criteria in performing a plant survey in search of practical and economical robot applications. They are that simple respective operations are needed. That is, cycle times are greater than 5 seconds. Parts can be delivered in a proper location and orientations. Part weight is suitable. 1100 lb is typically used as a upper limit, and no inspection is required. One or two persons can be replaced in 24 hours of period, and setup and changeovers are not frequent. If the potential application meets all these criteria, then they know they have a prime candidate. So in that case, you do selecting the right application for robot. Now we'll see some applications area for industrial robots. Industrial robots have been applied to a great variety of production situations for the purpose of organization. We will divide some applications into categories or categorized, and these are the some categorized. That first is material transfer. In material transfer, applications are those in which the robot is used to move work part from one location to the another. In some cases, reorientation of the part may be required in this material handling function. Some examples you can say here: simple pick and place operations, transfer of work part from one conveyor to another conveyor. It's basically pick and place only. And next is pelletizing operations, in which the robot takes part from the conveyor and load them onto a pallet in a required pattern and sequence. Staking operations similar to pelletization. Again, next is loading parts from the conveyor into cartons or boxes. Next is depetalization. Depetalizing operations, in which the robot takes parts which are arranged on a pallet and loads them onto a conveyor. Here, material transfer operations are often among the easiest and most straightforward of robot applications. Here, a robot used for these tasks usually possess a relatively low level of technological sophistication. However, in other case, the motion pattern required of the robot can become somewhat complicated. For example, pelletizing, each part must be positioned in its own location on the pallet for each layer, and often multiple layers must be stacked on the pellet, and the programming necessary to execute such motion sequence can become a quite involved unless a computer controlled robot is used. And if you see a machine loading applications are the material handling operations in which the robot is required to supply a production machine with the raw work parts and or to unload finished parts from the machine. Machine loading is distinguished from material transfer operations by the fact that the robot works directly with the processing equipment. In material transfer function, it does not. In the typical application, the robot would grasp a raw work part from the conveyor and load it into the machine. In some cases, the robot holds the part in a position during processing. When the processing is completed, the robot unloads the part from the machine and place it on the another conveyor. A production operation in which robots have been successfully applied to perform the machine loading and unloading functions including die casting, injection molding, transfer molding, hot forging, upsetting or upset forging, stamping, press operations, machining operations, such as turning and milling. In some of these operations, the robot only unload the finished parts. For machining processes, the robot both loads and unloads the machine tool. In offset and stamping operations, the robot holds the work part while it is being processed by the machine. Some machines loading application consist of several processing machines in a manufacturing cell, with the robot tending two or three or even four separate machines. One of the more recent invention in the machine leading applications is to form a flexible manufacturing system using several robots to augment the conveyor system normally used in these production cells. Next is the welding, where in the welding process are very important applications area for industrial robots. The applications logically divide some categories. We can say then spot and arc welding, isn't it? And here, spot welding, if you talking about spot welding, is a process in which the metal parts or sheets or plates are fused together at localized point by pressing a large electric current through the two parts at the points of contact, isn't it? The process is implemented by means of electrodes which squeeze the part together and conduct the current to the contact point. The typical pair of electrodes have the form of tongues, which can conveniently be mounted on a large robots with wrist as end effector. Using the welding gun as the electrode assembly is sometimes called, the robot accomplishes a spot weld by means of the some sequences. Here the position first is position of welding gun in the desired location against the two piece, isn't it? And the next one, the sequencing the two electrode against the mating pieces. And another is weld and hold when the current is applied to cause heating and fusion of the two surfaces in contact. And last is release and cool. The electrodes open and sufficient time is allowed to cool and electrodes to anticipation of the next spot weld. This is a sequence which has become an ideal task for the point-to-point robot. The spot welding has become one of the largest applications area for industrial robots, especially in the automotive industry. where during 1960s, the first spot welding robot had been installed for producing the Vega model automobile. Now, today, nearly all automobile manufacturers are using robot for spot welding car bodies, isn't it? And next is in welding, that is arc welding. If you're talking about arc welding, the several type of continuous arc welding processes can be accomplished by industrial robots capable of continuous path operation. These processes includes gas metal arc welding and gas tungsten arc welding. These kind of operations are traditionally performed by welders who must often work under conditions which are hot, uncomfortable, and sometimes dangerous as well. Such conditions make this a lo- logical candidate for the application of the industrial robots. However, there are several problems associated with arc welding which have hindered the widespread use of robots in this process. First, arc weld is a fabricated process often used on low volume products. Hence, the economics involved in these cases make the use of any automation difficult. Robot included, means robots included over here. The second is a dimensional variation in the components being arc welded are common. Human welders can compensate for these variations. Robots cannot, at least with current technology now. And third one is human welders are often required to perform their trade in areas which are difficult to access, means inside vessel, tanks, ships, hulls, etc. And the fourth and final is sensor technology capable of monitoring the variations in the arc welding processes have not yet been fully developed. As we can see here, these problems, robot arc welding applications have been fairly limited to operations involving high or medium volume where the components can be conveniently handled and dimensional variations can be reasonable managed. A typical robotic arc welding stations would consist of the some components that a robot capable of continuous path control. Second is the welded unit consists of welding tool, power source, and wire feed system. And third one is the work part manipulator, which fixture the components and positions them for welding. The workstation controller is equipped to coordinate the wire feed and arc voltage with the robot's arm movement. The activities of the work part manipulator must also be coordinated by the controller. A human worker would be used to load and unload the work parts from the manipulator. Next, if you see, there are several advantages attributes to a robot welding station compared with its manual operated counterpart. Uh, these are a higher productivity, improved safety, and more consistent welds, right? And if you see, the higher productivity results from the several factors. And first, as a human welder may weld with an average arc on time of 20 to 30%, while the robotic workstation can operate with the average of 60 to 70% arc on time. Hence, more welding is taking place at the workstation with a robot. Second is the use of the work part manipulators speeds up the loading and unloading time. The two fixture stations save even more time. And third one is The fatigue factor of the welder is reduced. Manual welding is a rather tiring operation for the welder because of the hand-eye coordination needed and the uncomfortable working condition. Consequently, the frequent rest periods are necessary, and these are not required by any robot. And finally, many manual welding stations use two workers, a welder and a fitter. A robot welding a station eliminates the need for the one of these workers. And note, however, uh, that the robotic workstation still requires a human operator to perform a welding process. Next is we are talking about what is this, spray coating. Here many large consumer products or most industrial products require the application of some form of paint. When human workers apply this paint, the most commonly method is spray painting. However, the spray painting processes possess certain health hazard to human operator, where fumes and mist from the spraying operation by these create an uncomfortable and sometimes toxic atmosphere. Even a noise from the spray nozzle, this noise is loud and prolonged exposure can impair hearing. And the fire hazard is also there. The mist of the paint in the air within the factory can result in the flash fires also, and the possible cancer danger even. And because of these health hazards, human workers are enthusiastic unenthusiastic about being exposed to the spray painting environment, and the companies have been forced by the federal law of construct elaborate ventilating system to the protect their workers. For these and other reasons, the specialized industrial robots are being used more and more frequently to perform spray painting and related processes. And spray painting requires a robot capable of executing a smooth motion pattern which will apply the paint or other fluid evenly and avoid runs. To accomplish this, the robot is equipped with continuous path control. And among many advantages using a robot for spray coating applications are a safety, coating consistency, lower material usage, less energy used, greater productivity even. And if you're talking about process operations, this is the miscellaneous category in which the robot is used to perform some manufacturing process other than the welding or spray painting. Assembly and inspection operations are also excluded, and they are covered in the following some section. Just as a welding and spray painting, the process operation is performed by a specialized tool attached to the robot wrist as it as its end effector. The end effector is typically a powered spindle which holds and rotates the tool such as a drill. The robot would be used to bring the tool into contact with the stationary work part during the processing. In some applications, which we will include within this category, the robot's hand is used for gripping the work part and gripping it into contact with a tool held in a fixed position. In the later case, we begin to overlap with the types of machine loading applications covered earlier in this video, right? Already some of the processing operations which have been performed by industrial robots including drilling, riveting, grinding, polishing, deburring, wire brushing, and water jet cutting. These are the some examples for the processing operations. Here, next one is assembly, where assembly operations are seen area big potential for robot applications. Batch type assembly operations seems to often the most promise for using robots. The reason for this based on the economic and technological capabilities for the robot. For mass production assembly, the most economical method involves the fixed automation, where the equipment is designed specifically to produce the particular product. A robot would be probably be too slow for mass production, and one of the robot's most important attributes, its programmability, would hardly be used. In batch assembly, there are variations in the products, and demand for each product is significantly lower than in a mass production, isn't it? And where inspection parts comes, like assembly inspection is a relatively new area for the application of the industrial robots. The traditionally the inspection functions has been a very labor intensive activity. The activity is slow, tedious, and boring, and is usually performed by a human being on the sampling basis rather than by 100% inspection. With ever increasing emphasis on quality in manufacturing, there is a trend towards automating the inspection process and towards the use of 100% inspection by machines instead of sampling inspection by human beings. An important role in this area of this inspection automobile will be played by industrial robots. And robots equipped with the mechanical probes, optical sensing capabilities, or other measuring devices can be programmed to perform a dimensional checking and other form of inspection operations. Right? And these are the some application industrial oriented applications. Next video we'll see the next topic. Thank you one and all.